How are you? How are you? Are you fine? Are you fine? Are you there? Are you? Are you there? Tell me something. Are you? Are you there? Okay. Okay, Valeria. Thank you, Julia. So let's get start. And okay, okay. Hello, hello, hello. Good. So now pay attention. Now pay attention. We're going to start with our class about natural science. And all of you, remember you have to have before you your notes, the page number 2, because we want to start with remembering the difference between heat and temperature. Today's class is composed of 3 things. A very little thing that is the explanation about theory, about how heat moves, and then we're going to watch some video clips, mainly about experiments. Okay, I hope you like them. And then we're going to revise some exercise you did the other day. So remember that the other day we talked about heat and temperature. And the first thing that we need to bear in mind is that it is one thing heat and quite another very different thing temperature. Okay, there are 2 different things. Heat is a form of energy, and this form of energy comes from the movement of the molecules in an object. Okay, and the more molecules you can find in an object, the more heat energy you can find there. Okay, and temperature is related to it, but it's not the same. Temperature is a measure that measures the speed, how fast these molecules are moving. Okay, this is very important, and you have to bear in mind because we're going to explain how heat travels. And you can read this part. So when 2 things are touching each other, heat will flow from the hotter object to the colder. So heat travels from the hotter object to the colder one. Why? Because you have a body, you have a liquid or a solid, and with a temperature. So the faster these molecules move, the faster this kinetic energy is transmitted to the other object. This is the important concept. We're going to see it in some experiments later. And the molecules in the hotter object will slow down, and the molecules in the colder object will speed up. So you have there this diagram. So hot, an object that is hot, and here on your right hand, an object that is cold, and heat travels from the hotter to the colder, from the hot object to the cold object. Okay, and eventually, at the end, they will get the same temperature, and this is called equilibrium. Very good. So with that in mind, I'd like you to watch to a video that explain it very easily. So pay attention to it. As always, if anyone wants these videos to watch at home, all you have to do is send me your request. Okay? Good. Pay attention now.
Why does heat transfer from hot to cold? Heat is a form of energy. When energy is added to atoms, they begin to move more rapidly. Think Think of it like kinetic energy. When you push a ball or add energy to it, it rolls. This means that the more motion atoms have, the hotter they feel to the touch. Back to the ball example. If you have a stationary ball and you impact it with another ball, the energy of the rolling ball is transferred into the stationary ball, causing it to move. You would say that the stationary ball absorbed the faster ball's energy. It wouldn't be right or sound right to say that the stationary ball transferred its stationary state to the rolling ball. The same is said about atoms transferring energy. The fast-moving atoms impact slow-moving atoms, transferring their kinetic energy. Therefore, to say heat transfers from hot to cold really means that energy is transferred from fast-moving atoms to slow-moving atoms. If you enjoyed this video, give it a like, be sure to subscribe, and check back next Wednesday for a new fact. Anyways, thanks for watching.
So, very good. So you remember? So the hotter object transfers its energy to the colder object. Why? Because the molecules in the hotter object are moving faster than in the other objects. And we have here another I think clearer video. So pay attention.
So what you see here is the beginning of two simple experiments to demonstrate what we've been learning in class. The first one will demonstrate the fact that when something is heated or warmer, the molecules are moving much quicker and faster. And when something is colder, the molecules are moving much slower. I have two small beakers here, and I'm going to be placing 3 drops of dye in each. And from the result, you should hopefully be able to tell which one is the warmer, heated up water and which one is the colder and thus molecules moving much slower water. Now, as you watch the dye disperse, you can notice that the beaker that I put the dye in second actually has the dye spreading out quite quickly. That's because the molecules are moving much faster and thus hitting the molecules of the dye and spreading them out. The first beaker, you can tell the dye is moving much slowly. In fact, you can still see parts that haven't even filled in yet. And that is because this water is much colder, molecules are moving much slower, thus not dispersing the dye as quickly as the first. The second simple demonstration will be of cold water, which will be, in this case, blue, and warm water, in this case, red, and I'm going to place them in the larger beaker. And we know that the molecules move faster when something's heated up. We also know that because they move faster, they're more spread out and less dense. Opposite being true for the cold. When it's moving slower, it's more compact and more dense. And we'll see what happens when they're placed in the flask of room temperature water.
The liquid is the colder liquid. Can you see it? The molecules moving very slowly. And the red beaker is the faster, is the hotter. And is the difference?
Now if you notice, the water that is much colder, which is colored blue, is not moving from the flask. It's actually much more dense than the room temperature water. Thus, it wants to sink and is just staying in the flask. However, the water in the flask that has been colored red, which has been heated, is rising. That's because it's much less dense than the room temperature water. Because by heating it, the molecules have been made to move much faster and have spread out, again becoming less dense. So this simple demonstration can show you that when something is heated, the molecules will not only speed up, the dye that spread out quicker illustrated that, but also spread out. As you can see, the red dye rising less dense than the room temperature water, while the blue dye wants to sink because it's more dense than the room temperature water, thus doesn't leave the flask. Simple experiment, simple results, hopefully easy to see, easy to understand.
So very good. I think this is a very clear experiment. And now let's go to our text and go please to the exercise section. And you have there the other day um, this exercise. So we want to do it because not all of you did it correctly. So, and this reads, read the text and answer the questions about these two examples. So, temperature and heat. Let's look at this example to see how thermal energy and temperature are related. A swimming pool at 40 Celsius degrees is at a lower temperature than a cup of tea at 90 Celsius degrees. However, the swimming pool contains a lot more water. Therefore, the pool has more thermal energy than the cup of tea, even though the tea is hotter than the water in the pool. Why is it? Because in a swimming pool there is much more water, much more mass. So, as there is more mass, more molecules, okay, and more thermal energy. So this is this example below. This represents the swimming pool, this beaker, and beaker B represents the cup of tea. So let's read. So A. It will take a longer time to bring the water in beaker A to boil. Why? Because there are a lot more mass here than here. If the water in both beakers are at 100 Celsius degrees, beaker B will cool off quicker than beaker A because beaker A has more thermal energy. As here we can find more thermal energy. That's the reason why this beaker will cool down slower than in this case. If we want to boil the water in these two beakers, we must increase the temperature to 100 Celsius degrees. You will notice that it will take longer to boil the water in the large beaker than the water in the small beaker. This is because the large beaker contains more water and needs more heat energy to reach 100 Celsius degrees. So this is the explanation. More mass of water, more thermal energy. Less mass of water, less thermal energy. Less thermal energy, but it can increase the temperature faster than in beaker A. And here you have some questions, and I like you to take part in the chat. So the first one reads this way: what is the thing that has more thermal energy? Thermal energy, not temperature. Swimming pool or the cup of tea? And why? So two answers. Swimming pool or cup of tea? We're talking about thermal energy. That depends on the amount of mass. And the answer is yes, more thermal energy in the swimming pool. Okay, and why is it? Because in a swimming pool there are more a massive amount of water. Okay, more water there. Let's move to number 2. What is the thing that has more temperature? The swimming pool or the cup of tea? And why? You can answer. Now we're asking about temperature. The swimming pool or the cup of tea? Very easy, the cup of tea. And why is it? Because as in a cup of tea, we can find lesser amount of mass. It's easier for the molecules to acquire the temperature and move faster. Number 3. Why will it take longer to bring the water in beaker A to boiling point? The boiling point in the case of water is 100 Celsius degrees. Okay, each liquid has its own boiling point. Its own boiling point, and in the case of water, the boiling point of water is 100 Celsius degrees. And why will it take longer to bring the water in beaker A to boiling point? Why is it? Okay, so the answer is because beaker A has more mass. Okay, more mass. And you know that when a liquid reaches its boiling point, the temperature doesn't increase until all molecules are turned into vapor. So, good. Number 4. Why will beaker B cool off quicker than beaker A? Why? Remember, beaker B is this part. Beaker A is this part. Question 4. Why? Because it contains a lesser amount of mass. And number 5. What's the difference between heat and temperature? The difference between heat and temperature. The difference is that heat is a form of energy, it's thermal energy, and temperature is a measure that measures the speed of the molecules. Okay, so temperature is related to how faster molecules in a liquid are moving. And to illustrate that, I have here some another interesting experiment. Now pay attention to this experiment about air.
Hi, I'm Jared, back with another simple science demonstration on the whole idea that warm air rises, cold air sinks. And it's true for water, and the cool thing about this is it's kid-friendly, kid-tested, mother-approved, nobody's going to get hurt. We have hot water, cold water, and we don't want kids dipping their hands in there, coming out with...
Can you see this is cold water? Can you see ice here? This is hotter, this is colder.
Third-degree burns. We want a safe way for kids to really look at what's happening, analyze it, think about it again and again and again. And that's what science is. So we have a very, very simple setup here. You can see I have a jar of water. It's hot, hence the red. I have a jar of cold water. It's cold, hence the blue. And all we're going to do is put the food coloring in. Take the lid off. You don't have to be conservative here. You just squirt it in. You want it to be a nice, dark, deep red. And watch how quickly that red actually disperses and just totally fans out in all of the water. It's not taking long. And compare that with the blue, because it's actually interesting scientifically what's happening here. Squirt some blue in past the ice. You can see the blue sort of stays together. It's not spreading out as quickly as the red. That's actually part of the process of what's happening here. The molecules here, the water molecules, are heated, so they're moving quickly. They're moving, and it's actually helping to stir up that water. You can't see it. Sort of an invisible stir. Here, it's not moving so quickly. You can see it's not really spreading out there. So I'm going to speed it up with my straw. Stir it up there. Stir this one up here. Make sure it's good and ready. Now what I want to do is create a column of separation between the two colors to see what happens. And it's a real simple principle. And we've all done this with soda. Stick the straw in your soda, put your thumb over top and pull it out, and the soda stays in the straw. Well, that's a different scientific concept. So we're focusing here on just one simple concept. So I'm going to start with the hot water first, dip it in, put my thumb on top, and ta-da, it's staying in there. Now here's the magic. And it's not magic, it's science. I'm going to move it over, put my straw deeper into the blue, let my thumb off, put my thumb back on, and trap the water inside. It sounds so complicated, but it's not. Here we go. Deeper, off, cap, and I have a beautiful column, and the red and the blue aren't mixing. I have the hot water on the top, the cold water on the bottom, and it's not mixing. Why? Warm air rises, cold air sinks. That warm water is a whole lot lighter and less dense than the blue, and it's not separating. I can look at it. I'm a kid. I'm not getting burned. It's beautiful. Now, if I leave this sit long enough, the temperatures will even out, and they'll start to mix. You can see it sort of starting to happen right in the middle. It's cool. What if we reverse it? That's where you see the science happen. So I'm going to start with the cold and then go into the hot. Have the kids think about what's going to happen. Have them predict. Have them make a hypothesis and test it. If they mess up, so what? You dump it out. It's cool. I have my blue. Now I'm going to go a little deeper. Take my thumb off. What happened? Almost instantaneously. They're mixing. You can see the red actually rising in the blue, and they're mixing. Why? Warm air rises, cold air sinks. Warm water rises, cold water sinks. Such a simple concept that kids can play with and learn about at the same time. That's science. I'm Jared. Thanks for watching.
Very good, very good, very good. So, this is important because you remember that when something is hot, it tends to go up. When something is colder, tends to go down. This is important. And let's see another experiment. Looking for it. This experiment was made by a kid like you. Now, pay attention.
In today's video, we are going to learn about the properties of warm air and cold air. Now, the things needed for the experiment are a balloon, a water bottle, some hot water and some cold water. Now, the procedure is take the balloon and put it on top of the water bottle like this. Now, place the balloon inside the cold water. As you can see, nothing happens to the balloon. When I keep it in the hot water, it slowly inflates like this. Now when I keep it again in the cold water, it will start deflating. As you can see now, the balloon is.
So the energy is transferring from the hot water to the cold water, from the cold water to the balloon, and from the balloon to the cold water.
Completely deflated. And now I again keep it in the hot water. Now you can see the balloon is inflated again. Now, do you know why this happens? I'll tell you. When we keep the water bottle inside the warm hot water, the heat from the hot water travels inside the bottle, heating the air inside. Since the hot air is lighter than the cold air, it moves up. When it moves up, it inflates the balloon here. Now, when I keep the bottle inside the cold water, the cold air is heavier compared to the hot water. So, nothing happens in that process. Thus, we know that warm air is lighter than the cold air. Please like, share and comment. If you like Adapters videos, please subscribe and don't.
Okay, so a very simple experiment you can do at home with the supervision of your parents. Okay, very good. And now let's move to our notes, and I'm going to explain you the exercises you have to do today about this theme. So remember, first thing is that you need to learn this part. It's very easy. Okay, so how does heat travel? Okay, from the hotter object to the colder one, and then with that in mind, you have to do two exercises. Number 4, so you have to take a look at this picture and explain this is a movement. So the red part corresponds to the hotter object, and the blue object is the colder, and this is the thermometer. Okay, so this is the temperature of the first object, and this is the temperature in the next object. This is the second step. Okay, because heat is flowing from the red object to the blue object. Okay, and finally, this is the final process. Can you see the same color? You have to explain that. Okay, you have to explain that in good English, this part. Okay, and you have to try and do the exercise number 5. Remember, you have to only one, or there is only right answer out of these 4 choices. Okay, not number 6, just number 5. And we're going to finish this class with another experiment. This is another very interesting experiment, and I'd like you to watch it very attentively.
Hello boys and girls, and welcome to Hoopla Kids Lab, making science super fun and super simple. Today we're going to show you a wacky water experiment that I think is really clever. All you're going to need to conduct this experiment is a jar of cold water, a jar of hot water, some blue and red food dye, a plastic card, and a dish. Make sure that one of your parents is around to give you a hand with this experiment. The first step is to pour the red food dye into the hot water jar, and then very carefully stir it around to mix the colour. Then use some of the blue food dye to colour the cold water. This means you'll have a jar of cold blue water and a jar of hot red water. Make sure that the water goes all the way to the top of the jar so that it's almost spilling out. The first step is to put your cold water jar inside your dish, then carefully cover it with the plastic card. The next step is to turn this jar carefully upside down. You'll see that the vacuum formed inside the jar holds the card onto the surface. Then have your mum or dad place the hot jar of water into the dish and carefully place the cold jar on top. You'll need to go around every side of the jar and make sure that the edges line up perfectly. Then get someone to very carefully pull out the card from in between the jars. As they do, you'll see that the water starts to mix, which forms a pinkish purple colour. As each of the jars mixes in with the other one, you'll see that the colour evens out completely.
Can you see? So the red liquid is hotter, so it rises up, and the blue liquid is colder, so it goes down. That's why they mixed.
This is because the water is very slowly mixing all of its molecules together. Now try this. Take the jar of red hot water, place the card on top, and repeat the same steps. This time the blue jar is on the bottom and the red jar is on the top. Have someone very carefully remove the card from the middle, and this time you'll see that the jars don't mix. So why is this? Is it the colours? No, it's not. In fact, the hot water has a different density to the cold water. It's very slightly less dense than the cold water, and so sits on top. When we compare them side to side, you'll see that the reaction is completely different. This is because the cold water in the first experiment is more dense than the hot water, and so sinks straight through all the gaps between the molecules in the hot water. And there we have it, a really simple, really cool science experiment. Show it to your friends and they'll have no idea how it works.
So very good. So with that in mind, I don't know if you have some questions. You have any questions? exactly what's that. You have any questions? So very good. Remember for next day, for tomorrow, because tomorrow we're going to continue with this theme. Okay, we're not broadcasting tomorrow, but you have to continue to study this part. Remember today you have to do the exercises 4 and 5. Okay. Very good. Very good. See you later, and greet teacher Javi on my part.